67, right? So problem number 67 then is Kepler's laws and satellites. So let me read it out loud. It says, what is the orbital speed of a geosynchronous satellite? What is the orbital speed of a geosynchronous satellite? What is the orbital speed of a geosynchronous satellite? And then it gives us an example out of the book. So here's Earth. And we have a lot of satellites in space. And what they do is they kind of orbit the Earth. Okay? And the question that they ask us is, what is the orbital speed? Okay? What is the orbital speed? And they said, from example 713 in your textbook. So we're going to, let me find the page number. So there was an example in your text. It was example 713. And so we're going to gather the information from that example. So 713 in your textbook says a geosynchronous satellite. And they give us a bunch of information. So let me read the example of 713, and then we'll get that information from there. Well, we need some information to calculate the orbital speed. So in 713 in your textbook, which is on page 242, okay, they give us a ton of information. And what they tell us is there's in that problem, they ask us to find a height. Okay? And basically, they wanted to know what was the altitude of the satellite. What would the altitude, so they gave some parameters. And so let me tell you what the question there was. It says, some communication and weather satellites are launched into circular orbits above the Earth's equator, so they are synchronous with the Earth's rotation. That's what geosynchronous means. That means it rotates around the Earth along as the Earth orbits. And so then it says, that is, they remain fixed or hover over one point on the equator. At what altitude are these geosynchronous satellites? Okay, so what they're saying is that as the Earth rotates, we'll put an X marks the spot on Earth. Okay, now Earth rotates. How long does it take for the Earth to rotate? We should be in courtesy mode. How long does it take for the Earth to rotate? Make one full rotation. 1 day, which is what? This takes 24 hours. Okay? And so what they're saying is that they rig up these satellites to kind of stay in that same position. So they hover over a location. Now what that means is that this satellite has to be a certain distance from Earth, and it has to have a certain velocity or speed. And based on the physics, we can calculate the height or altitude of the satellite and the speed based on the radius of the circular path it has to travel. Does that make sense? And it has to stay, in other words, it has to make one revolution in a 24-hour period. So that's what they were trying to explain to us in 7.13. Well, we need to figure out what the height is, and that will help us to determine what the orbital speed is. And so the height would be r, because it's really the radius of this orbital path. And in 7.13, they actually figured out what r was. they figured out that r was equal to 4.3 times 10 to the 7 meters. Okay? Now, I should probably point out that r is really the radius of Earth plus the altitude height. So in this example, they wanted to know the altitude height, but this, which is the radius of Earth plus the altitude height, is the total distance r. Okay? So the radius of the circular path, technically, that would be the center of the Earth, right? Going from the center of the Earth to where the distance the satellite is. That's the circular path. And we need that information. So there's a relationship between the tangential velocity and the radius of the circular path. Well, we know what r is. We just looked it up in the textbook, and it's a long, complicated process how they solved it, but that's what it is in the textbook. That's why they told it to us. Do I know what t is, and what does t have to be in? What are when we calculate a velocity, what are the units of measure? It's the distance over time. What's the unit of measure for distance? Meters. I've got meters. What about time? Seconds. So what do I need to do? I need to make some changes. So we need to figure out how many seconds there are in a day. So in one 24-hour period, one hour is how many minutes? 60 minutes. Okay. How many seconds are there in 1 minute? If I multiply that all the way through, won't they give me the total amount of seconds? What's that number? Yeah, it's a big number, right? 24 times 3,600. That's 60 times 60. So there's 86,400 seconds in a day. Okay? So to find, this is actually easier than it looks. So to find this velocity v, what we're trying to figure out is this velocity v, I just need to say 2 pi times 4.3 times 10 to the 7 meters divided by the time, which is 86,400 seconds. And notice that my units are meters per second. Let's do it. So I'm going to say 2 pi times 4.3 second e to the 7 divided by 86,400. So what is that? That's really fast. So that's saying that the velocity of this thing is about 3,127 meters per second. In other words, the velocity of this thing is about 3.13 kilometers per second, right? So when the satellite is 4.3 times 10 to the 7 meters up in the sky, so if there's a satellite right above us, and it was this distance away from us, in order for it to stay right above us, it has to literally travel 3 kilometers in a second. 1/1000, it just went 3 kilometers. to 1,000. It just went another 3 kilometers. It's pretty fast, isn't it?